Let's get going. The first thing that we're gonna have to do is we're gonna have to set up our infrastructure. So what I'm gonna be doing is first I'll zoom in, and I'm gonna use as package manager UV. So I'll do UV init, and that's how I initialize it. So now if you actually see here, I have these other files, and the second thing that I need is a virtual environment. So I'll do UV VM, and then what I have to do is I need to activate it. So this is the command for it. And now we are ready to do the first thing, how the base model works. So I'm gonna do UV add grok, because we're gonna be using grok for this. And I'm gonna change this from hello to main.py. And currently I don't need this, right? Now, one of the things that I hate about coding tutorials in general is that they are slow. And today, if you're coding in any kind of like way with AI, you copy and paste a lot and then you evaluate a lot. So what I'm going to do is I'm gonna copy this function over here, where I'm gonna have to tweak very little things to then allow us to get what we want. So you can see over here the function, and then we will have to call it. So it's not summarize page, but it's base chat. Okay, base chat takes a string, which is question, and then this question over here, I'm gonna pass it across to this prompt, and we're gonna leave it as it is right now. I'll explain this in a second. First thing that we need to do is we need to come down here, and we need to add UV add python -.env. Ooh, sorry. Now, what's happening? The first thing that we do is we import the library of grok. I need a virtual environment, because to use grok, I'm gonna have to use a key, and for that, I'm gonna add this .env. And something that I want you to pay attention to is that we should have had a file over here called initialization. So there we go. Now everything looks like a normal Git repo, and I'm gonna put over here .env and .vm. When I save this, you see that these two have gone gray. That's because now they're ignored by the Git. So that means that my source control, where essentially I keep all of the code, don't need to take these things in. Now, I'm gonna add over here in this .env something called grok API key. Now this is gonna be blurred simply because it's my private key, and obviously this is the secret that you need to be careful not to leak. And if you go to a lot of GitHub repos, you'll see that some of these are leaked. So I'm gonna save this file, and then I have everything that I need in there. Now, where were we? Forget this docstring. It's not necessary for this. It's just something to try, essentially, what we're starting with. Now, the model that I'm going to be using is a very old model compared to the type of models that we have today. Llama 3.1. I love this model. I feel like it's the only model that's still good from the Llama family. And what I'm asking it to do is essentially like, I want it to be Alex or Mozi, right? These type of models shouldn't have a lot of context around Alex or Mozi. I'm asking it to provide context from his book. He won't have any book context because we haven't given it that information yet. And I want it to be direct, confident, and all those type of things that Alex is when he's talking. Now I have put these settings over here for the model. These are quite standard. And reasoning format, we don't need that. That is for things like Quen or those type of models that are chain of thought. And this is how we return what the model is thinking or saying. So now I'm gonna call base chat, but for that first I'm gonna do this, and I'm gonna ask this question that my autocomplete just given me. Oh, I've closed that. And now if we come down here, I'm gonna do uv run main.py. This is how you run commands using uv. So hopefully this works, and this is what happens, right? Like, listen up, let me tell you something. Scaling a business quickly is not about being perfect, it's about being better than everyone else. This is cool, but this is missing a lot of context from how Alex behaves and how Alex talks in his videos. I'm gonna ask it something that should be fairly easy to say to answer for Alex, and is, what is a Grand Slam offer? And let's see what it says to us. Right, a Grand Slam offer. This is the holy grail of sales, my friend. It's an offer that's so good, so lucrative, so life-changing that it's a no-brainer for the customer. Checks all the boxes, addresses every single objection, every single concern, every single pain point. I wouldn't say that this is what Alex will talk about over here. That's the ice cream truck. This is a lot of work. Okay, well, we'll wait.
A few moments later.
Let me see if asking it, what are the components of a Grand Slam offer, we get a better response. So listen up, Grand Slam offer, so it's telling us pretty much the same thing as before. High ticket offer, the big kahuna, that's something that Alex never said. High ticket. Second, you need a low ticket offer. Third, you need a tripwire offer. Cool. None of this is what Alex talks about in his books. And this is the reason why I've chosen this model, because you can see really quickly that the moment that we actually put some of the cool information in, we're gonna be way better. And this model, even though it's very old and it's not at all the model that Alex uses, I'm not sure what Alex will use, but I'll give you at the end of all of these my guesses as to what Alex is using for this. None of this is here, so that's setting a fantastic base for all of us. Now I'm gonna close this main.py and we're going to move to the next thing, right? The first thing that we need to do is we need a book, or we need something that Alex has created for us to demo this. So I'm gonna copy this over here, and in the launch Alex gave away the lost chapters, which is essentially where Alex has put all of the chapters that he couldn't fit in the books. What I've done, because this came as a Google Drive file and it's got a watermark with my personal addresses and so on, I'm not going to show that, but what I've done is I've downloaded it as a TXT, as you can see over here on the extension. Okay, just going to check that everything's fine again. Yeah, here, TXT. Now I'm gonna only demo this with this simply because it's the easiest way. I don't need to work around PDFs and so on. I could do this with PDFs as well, it's not a problem at all, but what I wanted to show you is how easy it is if you're skilled enough to create something that works for you. Okay, this is not for production. Production is a different kettle of fish. Okay, this is simply if you want to have something that resembles Alex and you want to save yourself $6,000, well, you cannot access these anymore, but if you want to save yourself $6,000, this is how you can do it. Okay, so everything is here, and what I'm going to do to actually dump it into a database, what we need to do is we need to chunk this file, and what that means is we need to break it down into pieces. These pieces are the ones that I'm going to use later on to retrieve context around this book to help the model give us the response that we need, or get as close as it can to being the copy of Alex that we want in our chat model, okay? The decision that I've taken, given that this is pretty much in and out, is I've broken this down by page, okay? So this is the end of the page, this is the footer, and this is what I'm gonna split the pages by, okay? 6, if I keep scrolling down, look, this is number 8, and sometimes the footer changes completely and the number is at the end. So that's something that we're gonna have to account for. So we've chunked the pieces, we dump it into a vector database, and for that we're gonna use ChromaDB, which is fantastic open source tool for these things. And then we're gonna retrieve all of that, okay? So now, what is it that we need? I'm gonna close this and I'm gonna create another file that is going to be called dbdump. And this is how I've called it. And normally the type of structure that you would like for something like this is you will create a folder over here that probably talks about anything related to databases or backend. And then if you have any front end, you will put another folder with the front end, and then you will start splitting things in there. That's how most projects are. Now, I don't want to get too technical on this. I just want to get to the nitty-gritty of these things. Now, what is it that we need? I need ChromaDB, right? So I'm gonna have to do, as you can see, I'm adding ChromaDB to the system, and it's added all of these different packages. Now, what do I need to import? ChromaDB, of course. Ooh. Now, I'm going to need the regex library. So I'm gonna do that. And oops, the first thing that I'm gonna need after this is I'm gonna actually think of how I need to split the book. So let me just copy this across, because I obviously have all of this already written, but I just want to go step by step. Now, as you can see, what we're gonna have to do is we're gonna have to give it a book. And first, I'm gonna open the book, I'm gonna read it, and I'm gonna print how many characters there are in that book, okay? Now, I've created this regex over here, and I can tell you already, I was never good at regex, so AI helps me a lot with this, in which what I do is I copy the format that there is, and as you see, there is a string that's called numbers, spaces, and so on. And then there are two patterns that we need to find, as I've shown you. The first one is the number and the space before the copyright, and the second one is the space and the number at the end of it. So that's why we have pattern A and pattern B. Okay? Now, I'm going to combine them two to then split all of the pages of the book. And this is what this line is showing you over here. Finally, it's just a simple split. So we have the pattern and we have the text in the book. And then what I'm going to do is I'm just going to remove all of the weird spaces that happen when you do something like this. So it's kind of clean. And then we're going to see how many pages there are in total. Okay. Things that the system has split by and that we are comfortable that we can work with. So if I demo you this, if I do if name domain, okay, and I'm do book path equals 100, I'm just gonna copy this from here, relative path. There we go. So that's the book path, and then the second thing that I'm gonna do is I'm just gonna call the split text function, okay, and I'm gonna do book path, okay, right. UV run. This is obviously I have to save in the file. And look at this. So we have 130,000 words and 66 pages. The book is 70 pages, but it contains pictures, and I've skipped completely those in the TXT file. So 66 pages is quite reasonable, and everything's been broken down quite easy for this. Okay. Now, what do we need to do? We have the pages, so now we need to add them to ChromaDB. For that, I'm going to create this function in which I have, and I'm gonna put it up here, which is initializing Chroma. Okay, I'm gonna have to give it some data, and some metadata. And what is that? So the first thing is that you want to embed your pages to retrieve as context, and you want all of that context to return. You don't want to summarize or do anything like that. The metadata is the most efficient way for a system to then find the relevant piece of content that you want and how to retrieve it back. So with these two things, we can create a really efficient system to give us what we want, right? I've shown you that we have essentially this is how we create we have the data, and now we need the metadata. How do we create the metadata? So I'm going to bring this function over here to do this. This function, what it does is it's going to create a list, and then it's going to take all of the pages that we've broken down, and it's going to add these few things as a dictionary. So first it's going to be the page number, then it's going to be how long that page is, and this is just a good to have. This is not something that is going to move the needle a lot in terms of performance. And then we're going to get a summary. And as you can see, there is a function over here that we don't have, and this is why we get this error. I'll get to that in a second. Lastly, we get all of this list combined and we return it, okay? And this is what is going to go into this function. Now, what is the summarize page thing? So the summarize page is a simple agent that I've created. And I'm not going to use any libraries for this, but I am going to create a folder for this, and I'm going to call it agents. And within agents, I'm going to create this file that is going to be called summarize chunks agent.py. Okay? And now what I'm going to do is I'm going to do exactly the same thing that I was showing you in the main context as before. And this is the function that I was actually copying. So we get croc, and we get our secrets manager, the .env. And then what I'm going to do is I'm going to send a page of the book over here. The function is going to summarize it using Quen. And why do I use Quen? Modern models have been post-trained way better than older models. What does that mean? It means that if I were to ask Llama 3.1 to do exactly the same thing, it will probably be a really short and not actually valuable summary of that page. But using something like Quen 32 billion, which is quite recent, we significantly improved that response by a lot. And the reasoning format over here is hidden. So what does that mean? When calling Grok and calling a model that can reason, you can put this property over here that allows you to basically either print or not print the reasoning. And for my case, I don't want the reasoning. I just want the final response. How am I prompting this? I'm telling it to be a RAG engineer summarizing chunks of text. Is it a good prompt? It isn't. But it doesn't matter. The point is to get a summary. And you need that base context, essentially. And then I'm summarizing that with 50 to 100 words. Again, because it's a reasoning model, it's fairly new, is way better at following that instruction. And then the last thing is the page, okay? The page is what we're passing the function that you can see over here. Lastly, we return that response over here, and this is what we're gonna pass across to our function, which is here, which is where the metadata is. But for that, first, we're gonna have to do from agents summarize chunks agent, import summarize page. This is what we need to then not have this issue over here. Right, now that we have our function that adds all of the metadata in, we need to finalize our Chroma database. And for this example, we're keeping everything in memory. This is not a vector database that is gonna live in the cloud or anything like that. We're keeping this in our computer at runtime, okay? So it's consuming RAM. Fairly simple. It's just a demo project, but it's very powerful, you'll see. So how do we finalize that? The first thing that we need to do is obviously we need to get the metadata back into this function. And for that, we use a for loop that will allow us to zip the data with the metadata, meaning that we have a tuple. And then the collection, which is the chroma DB, which I'm calling my collection, it doesn't need to be, like we could put any names over here. I'm gonna add the documents. So I'm gonna give the page that it has. Then the metadata that is attached to that page as a tuple, as you can see over here. And then as it is, I'm just gonna give it different pages. And with these, ChromaDB gets the collection sorted and it resolves everything for you in terms of vector storage, which is really, really, really cool and easy to use. Now, how do we try all of this? So something that I want to show you is that you can actually, if I copy this across, we keep the clean pages after we split the book. We get our metadata from the clean pages. So essentially, once we have a clean page, now we need to get a summary. And that's what we're doing this. We're creating these two items over here that basically contain all of the information that we need to pass across. Now, why do I have this file call over here? This is simply because when you run the summary agent, it's going to take quite a while because first of all, you're kind of rate limited in terms of speed, even though Grok is quite fast, but it's going to take a little bit of time to get through the 66 pages. Then it needs to return all of those, and you don't want to be doing that all over again if you're just trialing the project or whatever. You want to keep that response if it was good, so you increasingly speed up the process. So this is why it's here. Now, I'm not going to run it. I already have that file. I'm going to show you that file. It's here. So page number 1, the content length is 13,000 characters. And then the summary is this. So Lost Chapters by Alex Hormozi is a 100 million series guide offering insights on high converting offers, customer acquisition, and business models. And it continues. Page 3. 1,929 characters. 40 excise sections from the author's work, section 8 detailed strategies for premium, free, and discounts, and da-da-da-da. And we can continue all these across, and you can see page by page what we have. Okay? This is how and why I did that, to save ourselves the hassle of having to keep on doing that, all of this continuously. Now, this is our pipeline done. We have 60 lines of code and we have everything that we need. Cool. Now, what else do we need? So if I go back to my main file, and this is what we need to get everything running. How are we going to... let me delete all of these, first of all. The first thing that comes to my mind is, if I want to use it for myself, I want a front end. Or something that resembles a chatbot. For that, I use something like Gradio. It's quite useful. So I'm going to do UV add Gradio. Cool. So we have everything in here. And that's pretty much it in terms of what we need to actually interact with our chatbot, or for somebody that is not as technical as us or that is learning to interact with our chatbot. Cool. So we have now our imports ready. And we're going to start by bringing here, again, all of the files and all the information that we've been working on over the last 10-15 minutes. So, what do we need? We need to again load the secrets. Then we need the Grok client, which I have it over here. We're loading all of our metadata, and we're getting the book and the collection initialized with the clean pages and the metadata that I was talking about a second ago. Okay, now what is it that we need to do? When you talk to an LLM, and if you want to do something like Alex's got over here, there are two things that you need to take into consideration. So one is memory, which is if I'm part of a conversation, I need to be able to remember what somebody's told me before. And second thing is I need to have the ability to retrieve the information that I have from my other memory, which is where we have put all of the documents that are related to the book. So what's the first thing that we're going to do? I'm going to bring this function over here, which is the one that allows me to format the history of the conversation in a way that works for me. Okay, so I have my messages and a history. So for every message in the history, I'm gonna have a look at the role, which is what I'm doing over here, and the content, and depending on what they are, I'm gonna append them based on the role and based on the content. And why do I do that? Is because when you are in a conversation with a chatbot, you take turns. So the assistant, which is the chatbot, takes turn, gives you a response or whatever you want, and then you take another turn. You go and ask more things, so you simply finish the conversation. So that's how we add all of this in. And as you can see, we need to handle this specifically for Gradio, which is what we're using. Okay, we want to return the messages back, and we want to use this after we've got the first conversation going. Now, what do I need? We need to bring the proper formula in, and this one is way larger. So let me bring it over here and let's go step by step. So this is our chat function, which is going to take a message and a history. And you might be wondering, why do we need that? Because we're going to use the memory that I just created, formatting the messages over here. So if we don't have any history, then the search query, which we will need in a second, will be our message, which is what we've inputted into Gradio. Okay, but if there's no history, we need to rewrite the prompt or the question to make sure that we retrieve from the database what we want. Now, why do we do that? Most systems, agentic systems, they have a way of reformulating prompts in a way that are optimal for the application that you're working in. So in our case, or in the case of the true Mozi AI, when you've put anything in there, there is, I'm sure, a layer before that looks at your prompt, makes sure that it's safe, that you're not trying to do anything fancy and extract any of the hidden information and so on. This is a different topic around security on LLM or agentic applications. And then after that, it will rewrite a prompt to maximize the efficiency of that. And this is because we know that LLMs are non-deterministic. So you want to maximize the chances of meeting the requirements or the expectations of the customer. So this is what we're doing over here. I'm rewriting the prompt. So given the chat history, which might be there, and given the new question that I have, can you reformulate the question? Okay. So this is what we're doing over here. It's very simple. A proper system like that routes in multiple different ways. So this is just like the most basic iteration of that. When we do that, we're gonna use Llama 3.1, which again, I love it, and is the same model, the same base model that I'm using to then retrieve all of the other information. And we're just gonna print this over here, just to basically be able to see here when we actually come down there to the terminal. Now, we've rewritten the query, and we need to send it to the collection. We essentially need to pick up from the collection. This is what is called tool calling. The way in which I'm coding everything is very archaic. Like, I'm not using any frameworks or anything. This is just pure code, like to simplify things as much as possible. So we don't need to, or I don't need to explain what the code behind the scene is doing or anything. This is just like what you see is what you get. So I'm gonna query the collection with the search query that we've rewritten, and I want to retrieve the first top 3 results. And how that works is you basically look at the cosine similarity, which is vectors in the mathematical space that are the closest to the pages that we have in the system, which have been encoded as well. So we can retrieve the most accurate information related to the topic that we're talking about. Now, to simplify things, even though I've returned 3 things, I just want to keep the first one. And what I'm gonna do is I'm just gonna add it to the context. So this is gonna be extra context that comes with the query that we've originally put. And now I have the system prompt again, which is the same one that we were playing with when I started the whole thing. And the thing that we need to take into account is that if we have memory, we actually need to put all of those messages again as part of the conversation, which is what we're doing over here. So this is the first message, and then what we're doing is we are appending the next messages, which is the history that we already had. So ultimately, now that we have the messages, what we're doing is just like, this is essentially like the last thing that we need to put over there, which is we have the messages, we've put it all, concatenated them all, and now we need to actually put the query itself that we're sending across, which I believe, if I'm not, yeah, actually that's a typo. So search query is what needs to go here. No, I'm telling a lie. So this is all fine. Like so this goes over here, which is the original message, which then is gonna go into all of these things. And then for this one, I'm using the new OpenAI model, just simply because it's a bit more powerful. But we can do the same thing with Llama 3.1. In fact, I'm gonna cancel this and I'm gonna bring Llama 3.1, so you can see, like we were saying at the beginning, how powerful it is. And then for the interface, we're gonna have to yield the response. So we're streaming the conversation, meaning that we're gonna get the tokens back as soon as we can, meaning that we can print them to the user, and it gives you that nice sort of like feeling that somebody is writing on the screen for you. And this is just the catch to see if there is an error. Now, the last thing that we need is our radio interface, and this is probably the simplest of all of it. We just create a chat interface that we're gonna call Mozi AI, and I'm just gonna give it kind of like a funky sort of title, and we're gonna launch it. Okay, so because my session closed, I need to activate again, and then I'm gonna do uv run main.py. Well, first of all, I'm gonna save the file, and then I'm gonna run this, and we get a little error over here. So this is an error in terms of, like, I think it's a saving error. Like if I do this, yeah, there we go. So it's because I didn't save the file previously, and then in a second we want to see that we can, yeah, there we go. So I'm gonna bring this over, and as you can see, this is MoziAI. So I'm gonna ask it, what is a Grand Slam offer? Where is my mouse? Yeah. If you think about it, because I haven't actually, let me just zoom out, because I haven't actually given it the Grand Slam offers book, we're not getting anything different. But I'm gonna ask it something that I know that there is in the book, and it is, how do I define an avatar? Now, in our conversation, this is gonna be part of the context, but I'm not too worried about it too much. So defining an avatar is crucial. It's a fictional persona. To define an avatar, I want you to answer these questions: who is your ideal client? What's their age? Job title, income, pain points. And as you can see, look, because the model is quite weak and old, you have this sentence over here. In the case of the gym owner I mentioned earlier, they were so to crowd an irresistible offer. So what's happening is, it's quite like it's picking up all of that context. So let's see, if we close this, you can see that one of the things that I wanted to show you, and I'll zoom in. Is this zoomed in? Yeah. So this was the original offer, and we keep having an offer. And then the second thing is like, look what's happened with the history. So I ask, how do I define an avatar? And then it's rewritten the search query. What is a comprehensive solution or offer that provides the highest value to a client? Again, the model is quite weak, so having more comprehensive models helps a lot with these things. I'm using this because I have quite like through Grok, it's good demo, but I will definitely recommend using one of the latest models to do this. Let's see what happens when we actually, like, we're gonna make a couple of changes. So one, we're gonna bring the new OpenAI model, and also I'm going to change it here for the rewriter model. So whoop. Right, and then I'm gonna save this, and let's see what happens when we do the same thing again. I would like to see an improvement over this question. Right, so we open this up, and I'm gonna ask, what is a Grand Slam offer? Now remember that because we're using a better model now, look at the difference. So we get way more information, but it's still not what Alex will say, because it's not the same thing, is it? Interview, quantify the value, set a price, add a wrapper, test and iterate. Okay, so it's still not the same thing. Now I'm gonna ask her the same thing. How do I find my avatar? Right, look at that. Wow, this is way better, huh? How to find your avatar. The first avatar playbook. You already have the raw material, your 16 customers. Survey. So I know for a fact that this is in the book because it's the first chapter. Build a short form. Offer a small incentive. 100% is there. So this is exactly how Alex's AI works. So I'm not suggesting that Alex uses something like OpenAI for his thing, but this is the premises and the basis of how acquisition.com is created their own chatbot. Now, a few things that I ought to mention about this, and it's that when you're trying to deal with loads of customers at the same time, this is becoming more of a software engineering problem than an AI problem. As you can see, all I've done is hook up a few APIs, right? But say that Alex did something, or Alex's team did something very complicated, which is fine-tuning a model, serving it, and all that type of stuff, which is possible because I think Alex is the type of person that will go the extra mile to give something valuable, right? That is a completely different project, and it's got risks. So if you fine-tune a model, like you run the risk of, in the next iteration of GPT, like GPT-5 or GPT-6, his model, where he could have spent millions to actually fine-tune it, if he's done it like in full, not just like a LoRa or something like that, like it could go in the bin. So these are the things that we need to trade off when we're looking at a prototype like this, or we're looking at servicing lots of customers with lots of information, right? Another thing is that I'm pretty sure that his RAG system, because this is RAG, it's got different layers, because he said that he had consultancy cases, so different businesses that he's helped on top of the books, on top of like all of the marketing materials that he's got, on top of all of the YouTube videos that he's got, and so on. It's a significant endeavor in terms of data engineering, because you need to feed all of that information, you need to retrieve all of that information, you need to make sure that, well, things scale and so on. So that's how it works. For me, this is like the closest I'll get for the time being to have Alex in my pocket. I hope you enjoy it, and I'll see you in the next one. Cheers.